valency concept, right? So we are dealing with atoms and molecules, okay? Atoms and molecules. But this lesson, there is a continuation part of the next chapter, that is structure of atom. What? Structure of atom. Okay. So both the lessons were completely included. Okay, both were interlocked with each other. So we simply deal with the both chapters, okay, simultaneously. So firstly, we need to know elements now. So major elements were, we need to know up to 18 elements. Okay, we'll deal with up to 20. So coming to the hydrogen, atomic number is 1. Okay, so I just written 1 at the suffix of this, right? So at the bottom layer of hydrogen, I just written 1. So atomic number might be written at the bottom, right? Helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, right? Next, fluorine 9, neon 10, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium, right? So these are the elements. Okay, we need to learn about this. Up to 20 elements were very, very important now, right? Coming here, we need to learn about K shell, L shell, if required M shell also, right? So firstly, let me tell you something. If you look into the atomic structure, okay, as Bohr said, at the center we contains a heavier particles exactly situated at the center of the atom, right? So that thing we'll simply call it as a nucleus, okay, and this nucleus is surrounded by orbits, and these orbits, in these orbits, and what might going to happen is the electrons might get revolves around the nucleus, right? So this is the situation that Bohr said, right? So it looks similar to the solar system, right? So if you consider this case, right? So as Bohr said, it starts with K, L, M. But suppose if you consider one more, it becomes N, right? If you add one more, it becomes K, L, M, N and then O, right? So these are the things that Bohr discussed. So as I said here, K, L, M, N. Why just mentioned K, L, M here? That's because the electrons might get revolve around the nucleus by placed on these fixed orbits now. Okay, let's discuss here. So for K shell, we have N values. N is equal to 1, N equals to 2, N equals to 3, N equals to 4. Okay, what is the use of these N values? Okay, so N values are very, very important to find the maximum capacity of the particular orbit, right? Suppose we have a formula to determine the highest capacity of the orbit. The formula is 2n square, right? Simply, suppose if you got it out, K shell maximum capacity of electrons is, just simply substitute the n value here. So 2 into 1 square, it becomes 1 square is 1, so 2 ones are 2. So the maximum number of electrons that could fit in K shell is 2 electrons. How many electrons? 2 electrons, right? So this K shell is fully filled, right? So if this K shell is fully filled and there is no more electrons in the outermost shells, then this structure is called duplet. What do we call it? Duplet. In the outermost shell, it contains 2 electrons. We'll call it as a duplet. Okay. So next, n is equal to 2, L shell, right? Just simply substitute n is equal to 2 here. So we'll say 2 into 2, 2 into 2 square. 2 square is 4 into 2, 4 2s are 8. So L shell contains how many electrons? 8 electrons, right? So let's put 8 electrons here. 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 electrons might get filled in the L orbit, right? If I want to put one more electron in L shell, okay, it doesn't fit here because its highest capacity is 8 electrons, right? So if any atom that gets filled, outermost shell might be filled with 8 electrons, we'll call it has a rule that is octet rule. What? Octet rule. So last shell must contain 8 electrons now. If it contains 8 electrons, it becomes, the atom might become stable. Yes. So that is the reason every atom wants to become stable by gaining 2 electrons or 8 electrons, right? Only some of the elements might get 2 electrons, but remaining all the elements get 8 electrons in the outermost shell. Okay, so this octet rule, so this 8 is called the magic number, right? That's because it creates a magic by having 8 electrons at the outermost shell. So that rule, what do we call it? Octet rule. So all the atoms wanted to gain 8 electrons in the outermost shell now. Okay, so if you want to consider M shell, if you substitute n value here, 2 into 3 square, it becomes 3 square is 9, 9 2 is 18. So M shell maximum capacity 18, and N shell n into 4. Okay, 4 square 16, 16 2 is 32. 32 is the maximum capacity for N shell, right? So I think you got a clear idea how to put these things, right? So let's draw different structures for every atom, right? Up to calcium. Okay, let's draw the same structure. So firstly, if you consider hydrogen, right, it looks like there is a small nucleus for hydrogen, and there is only, okay, you need to consider one thing. If the atomic number is 1, it contains only 1 electron, right? So that 1 electron gets fitted in the first orbit, that is nothing but a K shell, as we discussed before, right? So K shell contains how many electrons? 1 electron. We'll simply write 1 here. Okay, so if you consider helium, helium contains how many electrons here? Its atomic number is 2, so it contains 2 electrons. So simply I just wanted to do like this. No, nucleus contains first shell, K shell. K shell is fully filled with 2 electrons because its highest capacity is 2. Yes or no? Yes, its highest capacity is 2, so 2 electrons might get filled in the K shell. So as we discussed here, K shell contains 2 electrons. So helium contains a structure. Which structure it has? Duplet structure. You need to remember this thing, right? So it got a duplet structure because this shell gets fully filled, right? So coming to the lithium, lithium atomic number is 3. First shell is filled with 2 electrons, okay, but there is left with 1 more electron, right? Because 3 electrons might get filled, right? So now if you want to put 1 more electron in the K shell, it doesn't accept because K shell highest capacity is maximum reached, right? So you need to add 1 more shell, and that shell is nothing but K and L shell. L shell highest capacity is 8, right? So it easily fitted in the first. So we'll simply write 2 1 here, right? So just imagine the numbers and observe the diagram, you will get the clear idea, right? So coming to the beryllium, so beryllium, we have a nucleus at here. Okay, how many electrons it has? 4. So 1 and 2, and 2 electrons might get filled in the L shell, right? Okay, beryllium. So we'll simply write 2 over 2 here. So next, boron. Boron, first 2 electrons in the K shell, and next 2 electrons here. Is it 2 electrons? After 2 electrons, you need to put 1 more shell? No, because its highest capacity is 8. So it should be filled with 8 electrons, right? So it is 2 and 3. Coming to the carbon, okay, coming to the carbon, it is 1, 1, 2 in the K shell, and 1, 2, 3 in the next L shell, right? So it becomes 2, 4. Next, nitrogen, 1, 2 over here, and 1, 2, okay. So here, okay, carbon 4 electrons, and coming to the nitrogen, 1, 2, 3, 4, 5, 5 plus 2, 7 electrons, okay. So 2, 5, okay. Next, oxygen, oxygen contains nucleus, nucleus, and first shell 2 electrons, and next shell 1, 2, 3, 4, 5, 6, 6 plus 2, 8 electrons, wonderful, right? So overall, we just filled up to oxygen. Next, coming to the fluorine, if you look at the fluorine here, fluorine, right? Let's put the structure. It has a nucleus, and the nucleus contains how many electrons? 2 electrons in the first shell, and we'll call it as K shell. And in the next shell, so 1, 2, okay, 2 already, 3, 4, 5, 6, 7, 8, 9. Okay. So overall, how many electrons it get? 4, 3, 7 electrons, right? But it has a highest capacity of 8 electrons, right? So K shell, L shell, and M shell if required, right? So coming to the K shell, it has 2 electrons, and L shell, it has 7 electrons, right? So neon structure, it has 2 electrons in the K shell and it has 1, 2, 3, 4, 5, 6, 7, 8, 8 plus 2, 10 overall. So 2 and 8, oh wonderful. As we discussed here, if it contains 2 electrons, we'll call it as a duplet structure. And if it contains 8 electrons in the outermost orbit, it has a structure, and the name of the structure was, okay, it has a rule, that is octet rule. What rule? Octet rule, right? So if it contains 8 electrons in the outermost shell, we'll simply say it is a octet rule. Coming to the sodium, let's say 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 plus 2, 10 completed. But I want to put one more electron here. Is it possible? No, because it is already filled with 8. So we need to put one more shell here, and that shell is fitted with one more electron. So it becomes 2, 8, 1. First electron gets added in the M shell. Clear? So next, magnesium 2, 8. I am simply writing, okay, 2 electrons here, and then 8 electrons, and then just 2 electrons here. So 2, 8, 2. Then aluminum 2 electrons here, and then 8 electrons, and then 3 electrons here. So 2, 8, 3. And silicon 2, 8, 4, right? 2, 8, 4 electrons. And next shell, right? 2, 8, and 5. 2, 8, 5 here. And coming to the sulfur, 2, 8, and 6. It is 2, 8, 6 electrons here, right? As the number goes on, moves. Okay, so coming to the chlorine, we'll start here. So chlorine contains, let's say, 2 electrons, and then 8 electrons, and then here already 6 finished, right? 7 electrons. So K shell and L shell, K shell and L shell. K, L, M, K, L and M. K shell already contains 2, next shell contains 8, and next shell contains 7 electrons, right? So coming to the argon, 1, 2, it's overall 8, and again 8 electrons, right? So 2, 8, 8, yes. In the final shell, it also got 8 electrons, right? It also got the same structure. Which structure it is? Octet structure. Yes. So you need to remember these 3. And then coming to the potassium, 2, 8, 8. Okay. Okay, but it has a highest capacity of, next shell contains the highest capacity, because K shell contains 2, L shell contains 8, and M shell contains highest capacity of 18. But it doesn't allow one more electron to add into the next shell, but it simply send that electron to the next shell, because it just easily wanted to lose this electron. If it loses, it gets the octet structure again. Yes, so that is the reason it simply send you one more extra electron to the other shell. So it becomes 2, 8, 8, and next shell is N, 1. Okay, so the atoms always wanted the shells must be filled with 8 electrons over here. So that is the reason. So this one electron should be easily removed from it. That is the reason it sent the one more electron to the next shell. So calcium also did the same thing. 2 here, 8, and next shell contains 8, and next shell contains 2, right? It becomes 2, 8, 8, 2, right? So these were the normal situations where we easily fill the orbits with K, L, M, and N shells, right? So up to 20, this rule gets, okay, easily finished. So now up to here got completed, but the major thing is, yeah, as I said before, the main concept is valency, right? So the valency is nothing but the combining capacity of an element. Combining, which means hydrogen is going to combine with some more elements here, right? So suppose hydrogen gets combines with oxygen. Okay, 2 hydrogens combines with oxygen, we got a water, right? So they easily combine with one more, right? So suppose hydrogen gets combines with chlorine, and we got a hydrochloric acid, right? So they get combined based on the valencies, right? So we need to find the valencies with easy steps now. Rule number 1, while defining the valency, rule number 1 is, if the outermost shell, hydrogen contains the first shell and the last shell is 1, right? outermost shell contains 1, 2, 3 and 4. You need to remember these 4, right? If the outermost shell contains 1, 2, 3 or 4, okay, you need to put the same numbers as a valency. Okay, for suppose if the number is greater than 4, which is greater than 4, then you need to easily subtract it from 8, right? You need to subtract it from 8, you will get the value that is lower than 4, right? So it becomes 1, 2, 3, 4 is the valency for major number of elements here, right? So now let's see hydrogen. Hydrogen is an exception. Okay, hydrogen is an exception because hydrogen gets combined with its own, right? So that is the reason hydrogen contains a H plus. We'll deal with it later. So we'll deal with the ions, right? Next, I'll tell. Here, hydrogen has a valency of 1. That's because its outermost shell contains 1 electron. Okay, that is the first electron and also the last electron is there, right? 1. So coming to the duplet, it is already fulfilled. So there is no valency for it because it has a structure duplet. Helium is the exception here, right? You need to remember. But here, lithium, the outermost shell contains 1 electron. So it's, as I said before, if it is 1, 2, 3 and 4, you need to put the same number. So it is 1. And beryllium contains 2 over here, right? If it contains 2, simply put 2. If it is 3, 3, 4, 4. But it is 5. You need to subtract it from 8. 8 minus 5 is 3. And 6. 8 minus 6 is 2. Okay. And then if you come here, let's check the valency. Right? It becomes outermost shell contains 7 electrons. 8 minus 7 is 1. Here 8 minus 8 is 0. Right? And also it has an octet rule. It is also an exception for it. Right? So next 1. Last shell contains 1. 1, 2, 3, 4. Same numbers. If it is 5, 8 minus 5 is 3. 8 minus 6 is 2. And here also we would like to look here. Valency. 8 minus 7. 1 again. Octet rule, exception. 8 minus 1, sorry, if it is 1, 1 directly, 2 means 2, right? So this is the process to identify the valency of each thing, right? But you need to remember one thing. You need to remember whether these valencies were plus ones or minus ones, okay? You need to remember one thing. So simply we'll call it as an ion. What do we call it? Ions, okay? Let me tell you what are ions here. Ions are two kinds, man, right? If you consider the neutral atom contains a plus charge and a minus charge. Plus charge and a minus charge. This plus charge we'll call it as a cation. What do we call it? Cation. And this minus charge we'll call it as an anion, right? So cation, what it is going to do is it simply loses the electron, right? For suppose if there is a situation where if it loses 1 electron or 2 electrons or 3 electrons, but then what happens is it might get the structure relevant to octet or duplet rule, right? Then it simply loses the electron and it becomes a charge. Which charge? Plus charge, right? So cation loses the electron. Okay, if any element loses electrons, we'll put plus charge, right? If any electron accepts or gains an electron, okay, we'll put minus charge, right? For suppose let's see. While doing it, you will simply observe these things, right? So firstly, hydrogen, simply it is going to lose or share also. We simply say H plus or H minus here. It's an exception, okay? Don't consider this thing. Helium doesn't do anything because it doesn't have any valency. So it has 1 here. So lithium, if you look here, what happens is it has only 1 electron in the outermost shell. If it loses that electron, what happens? If it loses this, then it contains 2 electrons. It becomes a duplet structure, right? So lithium wanted to lose the 1 electron, or else if it wanted to keep this electron to be stable, you need to get the octet rule, right? So if it wanted to get an octet rule, it needs to get how many electrons? 7 electrons. Is it possible? So 7 electrons gaining is not so possible. So it simply loses this electron and becomes a positive charge. It becomes Li plus. If it is plus means it becomes a cation, which means it loses 1 electron. Clear? It becomes a cation. So suppose if you consider beryllium, it loses how many electrons here? It becomes 2, right? Okay. If it wants to get 8 electrons, it needs to get 6 electrons or it needs to lose 2 electrons. Then it will get duplet structure, right? So it simply chooses to lose, right? It is also becomes plus 2. Here also 3 electrons, either 3 electrons or 5 electrons. No, it simply loses 3 electrons, it becomes boron plus 3. Okay, and finally if we consider carbon, carbon has a similar situation where either loses or gains, right? It has a both, because losing and gaining were the same, right? For this, that is the reason. But coming to the nitrogen, 5 electrons, right? So losing 5, then gaining a 3, right? So gaining is so easy, so it becomes minus 3. Coming to the oxygen, oxygen also wants to gain 2 electrons here. And coming to the fluorine, fluorine chooses last shell contains, okay, its valence is 1, because last shell contains 7 electrons. Losing 7 electrons or gaining 1 electron. Gaining 1 electron is so easy, so it becomes F minus, and neon doesn't do it. And coming to the same situation here, if it loses 1 electron, it becomes a stable again. It becomes a octet rule, so it prefers to choose losing. Okay, so it becomes a plus charge. And magnesium did the same thing. It loses 2 electrons, it becomes Mg2 plus. And coming to the aluminum, it also loses 3 electrons, it becomes Al3 plus. Coming to the silicon, it has the same situation. So it either loses nor gains. So Si4 plus, Si4 minus. Sometimes they might prefer to share the electrons here. And coming to the phosphorus, it gains electrons, that is 3 minus 3, because minus means gains anions, right? So P minus 3 here. Silicon, okay, sulfur prefers to add 2 electrons here, S minus 2. Coming to the potassium did the same thing. Sorry, chlorine did the same thing. Cl 1 electron, Cl minus, and argon did nothing because it has an already rule, octet rule. So coming to the potassium, it is going to only 1 electron at the bottom, right? Becomes plus, and Ca plus 2, right? So these were the scenarios where you need to observe. Here valencies and ions were very, very important, right? So as we discussed here, these were only a single elements, right? Yes. So these single elements, to find the velocity of valency for these elements, okay, it's very simple logic, right? So you need to fill KLM shells first and then simply add valency by using these two rules. Rule number 1, if it is 1, 2, 3, 4 at the last shell, simply write this. If it is greater than 4, simply subtract it from 8. You will get the final value here, right? So this is about the valency. So this was very, very important. You need to learn every element. Up to 20 elements is very, very important for you guys. And along with this, I'll provide a PDF for it. Okay, simply observe that PDF. So if you note that values, Nana, you will get a clear idea about it, right? So thank you.